oxygen dissociation curve. What is the meaning of oxygen dissociation curve? The relationship between HbO2 saturation. Relationship between HbO2 saturation and oxygen tension is called the oxygen dissociation curve. That is, when we plot the graph, suppose this is the graph, oxygen tension in mmHg, and here the O2 saturation, HbO2 saturation, O2 saturation, that is here the 20, 40, 60, 80 and 100. Again here also the 20, 40, 60, 80 and 100. So when it is plot, you know that in the tissue, here in the tissue, in a tissue level and in a alveoli level, even lungs, or in it is also called the lungs level, alveoli level. Generally in a tissue level, the O2, the oxygen tension is near about 40, and in lungs the oxygen tension is near about 104, and HbO2, concentration of the HbO2, that is the oxygen when combines with that hemoglobin is produced, is called the oxyhemoglobin. So this percentage or the concentration is here below, and in that it is at this alveolar level it is a high. So the normal graph, it is a S type or it is a sigmoid type. It is a sigmoid type. But when O2 concentration, it is lower, when the O2 concentration is lower, then this graph, it left or it shifted, and when the CO2 concentration is it is a high, then it also shifted, and this is called as the Bohr effect. It is called the Bohr effect. That is, when the CO2 concentration changes, the oxyhemoglobin dissociation curve, it gets shifted due to the CO2 concentration. It depends upon the CO2 concentration. Here the high CO2 concentration, here it is a normal, and it is for low CO2 concentration. Low CO2 concentration. So this is called the oxygen dissociation curve. The 100% saturation is also rare. Saturation is rare. Maximum saturation is near about 95 to 97%, and it is present in a alveoli. In alveoli. Degree of saturation, it decreases due to the dissociation of HbO2. When the HbO2, it get dissociate, that is Hb plus O2, then the degree of saturation decreases. In tissue level, it is near about 30 mmHg. 30 mm Hg in tissue level. The O2 tension, partial pressure of the O2 is near about 30 mm Hg, that is 50% in at a tissue level. In alveoli level it is a higher, in tissue level it is a lower one. And this relationship between the HbO2 saturation and the oxygen tension, it is called as the oxygen dissociation curve. And the shifting of oxyhemoglobin dissociation curve due to the partial pressure of the CO2, due to change in the partial pressure of the CO2 in the blood, it gets changes and it is called the Bohr effect. So what is the another effect is the, what is the Haldane effect. Haldane effect. Haldane effect means the oxyhemoglobin, HbO2, oxyhemoglobin, it functions as an acid. It functions as a acid. And that's why here the pH of blood, it changes. It get changes. And that's why here the H plus ions and number of H plus ion, when the number of H plus ions increases, the HCO3, that is due to the increase in the number of H plus ions, the HCO3, that is the carbonic acid, it get dissociate into the H2O and CO2. It is called the Haldane effect. Haldane effect means the HbO2, it functions as an acid, and due to that the pH of the blood, it get changes, and due to the increase of H plus ions, the carbonic acid, it get dissociate into H2O and CO2. So what is the difference between the Bohr effect and the Haldane effect? What is the difference between the Bohr effect and the Haldane effect? Bohr effect and Haldane effect. Bohr effect means, in Bohr effect, that is the decrease in the affinity, decreasing affinity of Hb, decreasing affinity of Hb towards, that is the hemoglobin molecule, towards O2. And here in a Haldane effect means the increasing affinity towards O2. It is due to decreasing affinity of Hb towards O2. It is due to the increase in CO2 concentration. When the CO2 concentration increases, the oxygen is not combined to the hemoglobin molecule, and it is due to decrease in Haldane effect. It is due to the decrease in CO2 concentration. That is, the more amount of oxygen is present in the alveoli, then it combines to the Hb molecules. That is, the O2 combines with that Hb molecule. Due to that, when the CO2 concentration it increases, then the blood, pH of the blood, it become acidic. And when the CO2 concentration decreases and the O2 concentration is increases, the pH of blood, it becomes basic. And that's why here the oxygen molecule, that is the oxygen which combines HbO2, when it enters at a tissue level, here this oxygen molecule, it gets dissociates and the O2 releases into the tissue. O2 releases into the tissue. And here the CO2 concentration is less. In case of that alveoli in the lungs, here the O2 concentration is more and that's why here it combines with that Hb, that is the Hb combines from that O2 of that alveoli. So this is the difference between the Bohr effect and the Haldane effect. Then the pulmonary volume and the capacities, lung capacities. Pulmonary volume, pulmonary volumes, and capacities, lung capacities. There are the different volumes. Tidal volume. Tidal volume means the volume of air inspired or expired during normal breathing. नॉर्मल ब्रीदिंगच्या वेळेस जी व्हॉल्यूम, एअरची व्हॉल्यूम घेतली जाते, ब्रीथ केली जाते, त्याला आपण टायडल व्हॉल्यूम म्हणतो. अँड इट इज नियर अबाउट 500 ml. इट इज द व्हॉल्यूम ऑफ एअर inspired or expired during normal breathing. During normal breathing. Normal breathing. This is called the tidal volume. Inspiratory reserve volume. Inspiratory reserve volume means the maximum volume of air inspired during forced breathing. During forced breathing. When we breathe, during forced breathing, the volume of air, the total volume of air which is inspired during forced breathing, forced breathing, is called inspired reserve volume, and it is near about 2000 to 3000 ml. Then expiratory reserve volume. Reserve volume. That is the volume of air which breathed out or which expired during forced breathing. During forced breathing is called the expired reserve volume. After the normal expiration, after normal expiration, the volume of air which is forced outside, this is called as the expired reserve volume, and it is near about 1000 to 1100 ml. Then the residual volume, RV, residual volume is the volume of air remains left in the lungs, or the volume of air left in the lungs after expiration. After expiration is called the residual volume. That is volume of air left in the lungs after the breathing, after the expiration. Then it is called the residual volume, and it is near about 1100 to 1200 ml. Then dead space. Dead space means the volume of air present in the respiratory tract. Volume of air present in the respiratory tract, that is in the nose, nasal cavity, in the pharynx, in the trachea and the bronchi. Then it is called the dead space. Nose to bronchi. And it is not involved in the exchange of gases. It is not involved. and this is called the dead space. Then the total lung capacity. Total lungs capacity. Total lungs capacity means the maximum amount of air that the lungs can hold after the maximum forceful expiration. It is maximum amount of air in the lungs that the lungs can hold. How much quantity of the air the lungs can hold after inspiration. When you take the long breath, then how much quantity of that air it is held by that lung. Take a long breath and how many times you can hold that air. This is called the total lung capacity. That is what amount of the air you can hold after the inspiration. This is called the lungs capacity, and it is near about 5200 to 5800 ml. Then the vital capacity. Vital capacity means the air that can be breathed out after maximum inspiration. That is, after inspiration, what amount of the air you can breathe out. किती श्वास बाहेर टाकू शकता इन्स्पिरेशनच्या नंतर. This is called as vital capacity, and it is the total of tidal volume, inspired reserve volume, and expired reserve volume, and it is near about 4100 to 4600 ml.